Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run cluster analysis in Stata. Cluster analysis is a statistical technique used in social science to group individuals, objects, or variables that are similar to each other into clusters. This method helps researchers identify patterns and structures within a data, facilitating the understanding of relationships and group dynamics. Cluster analysis is one of the advanced statistical techniques used to identify, classify objects or cases into homogeneous sets that behave similarly or show similar characteristics. In a simple language, we can say that the group having similar feature is classified as a cluster. The analysis used to classify these clusters is known as a cluster analysis. Now, what is the difference between factor analysis and cluster analysis? We start with the objective. Factor analysis is used for reducing the data dimensionality by identifying underlying factors. Cluster analysis groups similar data points into clusters. Data type, usually continuous variables are used. In this case, can be used with various data types such as continuous as well as categorical. Primary use, data reduction and summarization. This is data segmentation and classification. Output, factors, the latent variables that explain variance in the data. Here, the output is we are interested in formation of clusters of similar data points. Technique, statistical technique to find latent variables. This is a grouping technique based on similarity or distance. Methodology involves calculating factor loadings and scores. Involves calculating distance and updating centroids. Assumptions assumes linear relationships among variables. No strict assumptions about the data distribution. Applications, psychometrics, social sciences, marketing research. Its application is market segmentation, image processing, bioinformatics. Common algorithms used in factor analysis are principal component analysis and maximum likelihood. In case of cluster analysis, it is K-means, hierarchical clustering, DB scan. Dimensionality, it reduces dimensionality of the data. This does not reduce dimensionality, groups existing data. Interpretation of factors can be complex and subjective. Clusters are typically straightforward to interpret. Dependency, variables are assumed to be correlated. Here, no assumption of correlation between variables. Variable relationships, it identifies the relationship between the variables. It identifies the relationship between the observations. We will see the last difference in the next slide. Just see here. Factor analysis runs on variables, whereas cluster analysis runs on cases. I repeat, factor analysis runs on variable. Cluster analysis runs on cases. Now we'll understand the concept of cluster analysis with these shapes given on the screen. In how many ways we can cluster these shapes? One, on the basis of the shape. Second, on the basis of color. So you can see according to the shape. What name we will give to the first cluster? These are triangles. These are squares or rectangles, and these are circles. On the basis of color. On the basis of color. On the basis of sum of internal angles. Now, what are the types of data on which we can carry out the cluster analysis? It's a interval scaled variables, binary variables, nominal, ordinal, and ratio variables, variables of mixed types. All these variables can be considered for, that is, the variables of all these types can be considered for cluster analysis. What are the examples of cluster analysis? We talk about market segmentation, in that customer segmentation. Companies use cluster analysis to segment their customer base into groups with similar purchasing behaviors, preferences, or demographics. This allows for the targeted marketing strategies and personalized customer experiences. Can be also used for product positioning by identifying clusters of products that appeal to different market segments. Business can better position their products and tailor marketing campaigns. Public health, disease outbreak investigations. Health organizations use cluster analysis to identify patterns in disease outbreaks, determining which populations or regions are most affected and devising the targeted intervention strategies. Health risk assessment. Cluster analysis can group individuals based on health related behaviors or risk factors, helping in the design of preventative health programs. Social media analysis, user behavior. Social media platforms use cluster analysis to group users with similar behaviors, interests, or interaction patterns. This information is used for content recommendations and targeted advertising. It's also used in community detections. Identifying clusters within the social networks helps in understanding the structure of online communities and spread of information or influence. Crime analysis, crime hotspot detection. Law enforcement agencies use cluster analysis to identify crime hotspots by analyzing spatial and temporal patterns of the criminal activities. Offender profiling, clustering criminal profiles based on the behavior patterns, modus operandi, and demographic characteristics to assist in investigations and prevention strategies. Now, what is the minimum sample size required for carrying out the cluster analysis? Forman 1984 suggests a minimum of 2M cases where M is the number of variables. For example, if you have 10 variables, you need at least 20 cases. Dalnica recommend a minimum of 100 cases regardless of the number of variables to ensure stable clusters. Everett proposed that the number of cases should be at least 5 times the number of variables. For instance, if you have 10 variables, you need at least 50 cases. For hierarchical clustering, Burns and Burns suggest a minimum of 150 cases to avoid overly fragmented clusters. Hare et al. Recommend considering the purpose of the analysis, the heterogeneity of the population, and the desired precision of the results when determining the sample size. They advocate for a balance between the statistical power and practical constraints. Hierarchical clustering. Hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of clusters. It is divided mainly into two types. One, the agglomerative, that is a bottom-up approach, and the divisive, top-down approach. Agglomerative hierarchical clustering. In agglomerative hierarchical clustering, each data point starts in its own cluster and pairs of clusters are merged as one moves up the hierarchy. In case of divisive hierarchical clustering, all data points start in one cluster and splits are performed recursively as one moves down the hierarchy. We will try to understand this concept by a small example. You can see some fruits here: apple, orange, pear, grapes, and banana. We are going to use agglomerative hierarchical clustering, that is bottom-up approach. These fruits will be merged on the basis of shape, color, or taste. You can see first cluster has been formed. So this is on the basis of shape, this is on the basis of color. So we are moving bottom up. Again, you can see the banana has been merged into this cluster. And finally, all of them get merged into one cluster, which is known as fruits. Now, what will happen in the divisive hierarchical clustering? We start from top, and this is known as a top-down approach. Okay. Cluster formation. Clusters are formed in data clustering algorithm based on the distance between the data points, which measures their similarity or dissimilarity. This process involves grouping data points into clusters where points within the same clusters are more similar, less distance to each other compared to the points in other clusters. Different clustering algorithms use various distance metrics, such as Euclidean distance, Manhattan distance, or others, to quantify the distance between data points and determine the cluster formation. This iterative process aims to maximize intra-cluster similarity and minimize inter-cluster similarity, ultimately resulting in the formation of cohesive and distinct clusters in the dataset. Now, how to measure the distance between two clusters? We are having three methods. Most of the time, we work on first two methods only. Euclidean distance. This one. Imagine you are in a city and want to know the straight line distance between 2 points. Euclidean distance is like measuring this direct as a crow flies distance between two locations. So it's a direct distance. It's the shortest path you could walk between them. Manhattan distance. Imagine navigating a city where you can only travel along the streets that form a grid. Manhattan distance measures the distance you would walk to get from one point to another by moving along the streets, like walking along the avenues and streets in Manhattan, and then making a right angle turns to reach your destination. It's named after the street grid layout of Manhattan, New York City. So most of the time we work on this two only. Steps for hierarchical clustering. Calculate the distance matrix, that is, calculate the distance similarity between every pair of data points using a distance matrix. Don't worry, you don't have to do it. The algorithm will do it for you. Then merge the closest clusters, find the pair of clusters that are closest together and merge them into a single cluster. Update the distance matrix, recalculate the distance between the new cluster and each of the old clusters. Repeat steps 2 and 3 until all points are merged into single cluster. The software will take care of all of this. Distance between two clusters. What are the approaches available? The first is single linkage, nearest neighbor. In this method, the distance between two clusters is determined by the distance of the two closest objects, the nearest neighbor in the different clusters. Let's see the example. This is single linkage. Cluster A, cluster B. We are finding the distance between these 2 points, which are very nearer to each other. So that's the reason it is known as nearest neighbor. Complete linkage, furthest neighbor. In this method, the distance between the clusters are determined by the greatest distance between any two objects in the different clusters. Just see this. This is the farthest points. Complete linkage. Group average linkage. In this method, the distance between two clusters is calculated as the average distance between all pairs of objects in the two different clusters. So we take the average of this. Wards linkage. In this method, we try to minimize the variance of the merged clusters. Wards method is preferred in cluster analysis because it tends to produce compact, homogeneous clusters, that is, equal size clusters that are stable and interpretable, making it robust and reliable choice for hierarchical clustering. We are using Wards linkage method most of the times. Okay, let's proceed further. Now we'll go in Stata. So first of all, I will import the dataset. I'll go in File, Import, Excel, Browse, VCR, Open. Import first row as a variable names. Click here, click OK. So on the right hand side, you can see the characteristics of the VCR and the brand. But still I insist that you run the browse command so that you can see the entire data frame. So the brand of the VCR, price of the VCR, picture quality 1, 2, 3, program, reception 1, 3, audio 1, 3. So we will consider only the variable still audio 3 for our analysis. Close this. Now we will go in statistics. In multivariate analysis, cluster analysis, cluster the data, and Wards linkage. Please remember these steps: multivariate analysis, cluster the data, Wards linkage. Click on it. Now we want to select the variables from price till audio. So don't go on selecting everything one by one. Just write this way: price dash audio 3. All the variables will be selected, which are between price to audio 3. Distance, we have already talked about this. We'll select Euclidean distance. Other also are available, but we go for Euclidean distance. Here, keep the things as it is and click OK. So the cluster has been formed, the cluster 1. Now, again go in statistics, again go in multivariate analysis, cluster analysis, and post clustering. Please remember, post clustering. Click on summary variables from clusters. Please remember this. Multivariate analysis, cluster analysis, post clustering, summary variables from the cluster analysis. Click on it. Now right here, the name of the variable which you want to create, a new variable which you want to create, how many groups we want to form. So it will be 3 groups. So write down 3 groups, click OK. Now again, browse and just see on the right hand side, a new variable has been formed specifying that this brand of VCR falls in which group. Okay, see on the right hand side. Now close this. Again go in statistics, multivariate analysis, cluster analysis, post clustering, dendrograms. Now cluster 1 will be active. From here, activate brand, because we want to give the name, that is a leaf labels, we want to have it. Activate horizontal and click OK. So we got this results, right? Now let's start with the interpretation. And here is the interpretation, dendrogram. Okay. Each brand starts as its own separate entity at the left. Brands that are more similar in terms of the selected features such as price, ratings, and attributes are joined together at a shorter horizontal lines. See this. This one, they are having similar features and they are placed nearby with each other. As observed, there are 3 clear clusters that can be identified by drawing vertical line at a certain distance threshold. You can see these red lines. For example, the top section, this one. So this forms one tight cluster indicating high similarity among these brands. The middle section, this one, forms a second group which is moderately similar. The bottom section forms the third group, also shows high mutual similarity but distinct from others. The dendrogram visualization helps in identifying which VCR brands are closely related in the market and supports segmenting brands for targeted marketing, product positioning, or further analysis. Now let's go back again into Stata. Now what is the next thing which we want to do? You will go in statistics, summaries, frequency tables, one-way table, and here identify the variable group. This is the variable formed by us. Click OK. So in group 1, there are 5 brands. In group 2, 9. In group 3, 7. Let's write the interpretation for this also. So group 1 contains 5 brands representing 23.81% of the total VCR brands analyzed. Group 1 is the smallest, indicating fewer premium brands in the market. Group 2 contains 9 brands making up 42.86% of the sample. This is the largest cluster. Most VCR brands fit into group 2, suggesting a dominant market segment with a moderate features and prices. Group 3 contains 7 brands, which accounts for 33.33% of the brands. Group 3 occupies a significant portion, showing a notable presence of budget or entry-level brands. Now we want to have the summary statistics of all these groups. So again go in statistics, summaries, other tables, compact table of summary statistics. Click on it. Now, right here, price till audio 3, and in this activate group which we have created and click OK. So we got the output. So what is the average price of VCR in group 1, group 2, group 3? Picture quality, that is a picture quality 1 in group 1, 2, 3. You can see the picture quality is deteriorating, prices are dropping, reception, audio qualities. Okay, now we will write the interpretation on the basis of two tables. So this is the first output and this is the second output. From where we got this, it is from here. Brand and group. Now let's write the interpretation. The clustering groups VCR brands into three distinct categories based on their pricing, feature scores such as image, program, reception, audio, and overall appeal. Group 1, premium VCR brands, the group 1. And these are the VCRs in group 1, wherever it is written 111. Brands are mentioned here, features, highest average price and perfect feature ratings. Interpretation. These are top tier VCR brands positioned for consumers who prioritize advanced functionality, image quality and audio. They likely offer robust programming features and best-in-class reception and sound. Marketing focus. For the discerning buyer seeking the best performance. Next is group 2. This one, group 2, wherever it is written group 2. So these are the brands of the VCR in group 2. Features, moderate price, average feature scores. Interpretation. These VCR brands appeal to a wider consumer base, delivering solid performance with balanced features at reasonable price. They present ideal choices for those valuing both quality and affordability. Marketing focus. Reliable performance at a fair price. Then group 3, the last line, and here wherever it is written 3. These are the brands, features, lowest price, lower feature ratings. Interpretation. These brands target price sensitive consumers, likely offering simpler models with basic functionality. They may lack advanced image, program or audio features but provide essential performance at the lowest cost. Marketing focus. Affordable solutions for basic needs. So this was all about how to do cluster analysis in Stata. For more videos on Stata, kindly refer to my playlist. I have also uploaded many videos on data science, machine learning and artificial intelligence on my YouTube channel named Dhaval Maheta. To watch the full videos, please subscribe to my YouTube channel and check the playlist. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.